Okay, so in the second part of third lecture, we are going to discuss some basic properties of the probability, but there would be for sure the properties of set theory as well, because whenever we are discussing the probability of things, we are not out of the set theory, we are learning the things with the help of that. So we already know about the union and intersection of the sets. Let us just revise it. Whenever we are talking about the union of two sets, we say that, for example, if I have sets A and B, their union, we show it with this sign, A union B. So by union we say that all the elements which are either in A set or in B set or in both of them, that's simply the union of both the sets. Similarly, if those A and B are events, by A union B we mean an event. What? If A is an event, B is also an event, their union would also be an event, and we would say that A union B is an event which contains the sample points of event A or event B or both. So we simply say that if this is my sample space and this is my event A and event B, by union of it we say that take all the sample points which are in A only, all the sample points which are in B only, and all the points which are in both of them. Take all the sample points, all the possible outcomes that are the part of A event, that are the part of B event, and that are the part of both event A and B. If you sum up, if you collect all those outcomes, if you collect all those sample points, you got another event, that is the union of event A and B. Similarly, we define the intersection of the events there. By intersection, we simply say that intersection of two events is another event that contains the sample points from both the events A and B. If we are showing it like this, we would say if this is my sample space and this is my A event, this is B event, their intersection is only the sample points, the only outcomes which are the part of both events at the same point, at the same time. All the sample points, all the experimental outcomes, all the possible outcomes which are the part of event A as well as the part of event B would be the part of event A intersection B. If I take any outcome from this point, that outcome would be the part of A, not the part of A and B at the same point. So this would not be the part of A intersection B event. Similarly, if I take any possible outcome from event B that is only present in event B, it's not included in event A, it's not counted in event A, so this would not be applicable, or this would not be a suitable candidate for the event A intersection B. Similarly, if I take any sample point outside A and outside B, that would also not be the part of A intersection B. So now if we sort of try to make a relation for sets using set A, B and their intersection and union, or we start making any relation for events A, B and their union and intersection, we would simply get a simple relation like this. If I am defining union now, so if I say that I am interested in the event A union B, how can I get the union out of this picture? I would definitely say that if you are going to count for the union, we know that for union you take all the elements of A as well as of B and all those elements which are in both A and B. So I can simply say that if you want to take all the elements in A union B, you take all the elements in set A or in event A, take all the elements in event A. So means I took this whole set or I counted this whole event. Similarly, take all the elements in set B or in event B. Once you took all the elements in A event and you took all the elements in B event, you took for the A union B, but you did something wrong, like you counted this part 2 times. Once you were taking the elements of set A or event A, you took that part, you counted this part. Similarly, when you were taking the elements of set B or event B, you again counted this part. So you need to subtract that part once, that is subtract A intersection B for a single time. Now if we divide both the sides with the number of elements in the whole sample space, we would get the relative frequency for A union B, which would turn out the probability of A union B, the relative frequency for A, which is the probability of event A, relative frequency for B, that is probability of B, and the relative frequency for A intersection B, which would turn out to be the probability for A intersection B. So here we say that the probability of something to be in A or in B, what? The probability of anything to be inside A or inside B is the same as the probability of that thing to be in A or the probability of that thing to be in B set or B event minus the probability of that thing to be in both simultaneously. And this relationship is called the addition law of probability.